So in this lesson, we're going to be solving real-world quadratics, and we're going to be using this equation right here. H of t is equal to I minus 16t. So really quickly, I'm going to give us some context of this equation. So no matter the weight of an object, the Earth's gravity pulls the object down to the ground at the same rate. So in other words, if you have this object and you have this bigger object, and here's the ground, as these are falling, gravity is pulling the two objects towards the ground at the same exact rate, regardless of how heavy they are. And the longer the object falls, the faster it will fall. So every second an object falls, it falls 16 feet per second faster. Okay, so here we have this equation, and the height, so when I say height, I mean the current height of an object, can be calculated using the formula which subtracts the distance an object has fallen. So we're subtracting the distance an object has fallen from the initial height of the object. So this is the initial height of the object. So let's say that this building is 30 feet tall. That would be the initial height of the object. So the height of the object is equal to 30 minus 16t squared. And this is again about us just letting go of an object. So if we hold an object and as it travels to the ground, what will be the height of the object after a certain amount of time? So after 1 second, after 2 seconds, after 3 seconds, so on and so forth. We'll use this equation actually in a different form. So I'm just going to use the commutative property of addition to switch these two numbers and make it so it's negative 16t squared plus I. That's how we'll use it. Let's do an example. It'll give you a little bit more context. Mike dropped a rock off of a cliff 1,600 feet above the ocean. So that's going to be your initial height. It's 1,600 feet. You can see that here. He dropped the rock, and the motion of the rock can be modeled closely by using this function. So the function h of t is equal to negative 16t squared plus 160, where h of t represents the height of the rock after t seconds. So what is the height of the rock after 1 second? So this is where t equals 1. So we're going to do h of 1. Notice what I've done is I've substituted the 1 in for t here, and I'm going to substitute it in here. So h of t is equal to negative 16 times 1 squared plus 160, or 1,600. Simplify. 1 squared, so that's 1 times 1 is 1. Negative 16 times 1 is negative 16. And negative 16 plus 1,600 is 1,584. And this is height. So this is the height of the rock, which will be feet. Okay. So what this means is that the rock is 1,584 feet above the ground after 1 second. Okay? When does the rock hit the water? So if we're talking about when, we're solving for time. And when does it hit the water? So this is where we have to make a little bit of an inference. So if this is our image, and you're dropping a rock, we're wondering after how much time does the rock actually hit the water, which means when the height is 0. So the inference we have to make is that when it hits the water, it's now at a height of 0 feet. So really, we're substituting 0 in for h of t. So 0 equals negative 16t squared plus 1,600. This is now a quadratic. I can go ahead and factor out the GCF. So negative 16t squared minus 100. I'm going to use the difference of squares method. So t plus 10 and t minus 10. Now I'm going to use the zero product property to solve for t. So t plus 10 equals 0, or t minus 10 equals 0. Subtract 10, t equals negative 10 seconds. Add 10, t equals a positive 10 seconds. So when does it hit the water? It hits the water after negative 10 seconds. It hits the water after positive 10 seconds. Does it make sense that the rock hit the water after a negative 10 seconds? Do you know what a negative 10 seconds looks like? So we actually throw that answer out. And so after 10 seconds, the rock is actually going to hit the water. So it's kind of flying through the air for 10 seconds, and then after 10 seconds, it'll splash into the water. Okay, so this is another equation, and this equation is just slightly different. You'll see the negative 16t squared and the I in here, except we're also including v of t. And v of t is the distance traveled due to velocity. And so the difference is this equation is used when we throw objects. So imagine if you're staying on top of a building and you throw an object straight up. So the object is going to go up before it starts coming down. And the difference between that and this is that this is when you just drop it, so you let go of it. This is when you throw it straight up, and so it's going to add time to it. So let's take a look at this example here. So this says, from the edge of a 160-foot cliff, Peyton throws his math binder straight down with an initial velocity of 48 feet per second. So h of t is equal to negative 16t squared minus 48t plus 160. So what's the height of this should say binder, after 1.5 seconds? So this is where t equals 1.5. So we're going to do h of 1.5. And that equals negative 16, 1.5 squared, minus 48 times 1.5, plus 160. Zoom in. I'm going to simplify. 1.5 squared. That's going to be, that's going to be 2.25. 48 times 1.5 is 74.25. This is negative 36, negative 74.25, plus 160. Do all this work in my calculator, and I get 49.75. So after 1.5 seconds, the binder is at 49.75 feet above the water. To give you a visual, so that means that this cliff ride is 160 feet, and he threw it straight down, and after 1.5 seconds, it's only 49.75 feet above the water. So it's traveled quite a distance, and now it's almost hitting the water. So the next question is, when does the binder hit the water? So when we're solving for t, we don't know how much time. Does it hit the water? And if it hits the water, then that means that the height is 0. So 0 equals negative 16t squared minus 48t plus 160. This is a quadratic that we can factor. Let's start by factoring out the GCF. So that's negative 16. We're left with t squared plus 3t minus 10. I'm going to factor this into two binomials using the box method. First term, first box. Last term, last box. A times c goes in the t-chart. 10 is 2 times 5. And a positive 5t and a negative 2t would give me 3t. So t plus 5, t minus 2. So t plus 5 equals 0. This is the zero product property. Quickly solve this. So after 5 seconds, negative 5 seconds, the binder would hit the water, or after 2 seconds, the binder would hit the water. So what makes the most sense is after 2 seconds, the binder will hit the water, which makes sense because after 1.5 seconds, it's almost hitting the water. So then after that next half second is when it actually hits the water. Okay. One last one. We're going to evaluate h of 0. And so let's go ahead and do that quickly. H of 0 is equal to negative 16 times 0 squared minus 48 times 0 plus 160. Well, 0 squared is 0, and 0 times negative 16 is 0. 48 times 0 is 0, and so h of 0 is 160. So this was t. So after 0 seconds, the height is 160 feet. Which makes sense because at 0 seconds, the rock is still in his hand, which is 160 feet above the water. So what I really want you to conclude is that at 0 seconds, the rock is still in his hand. That's 160 feet above the water.